Good morning, everyone. Today, inshallah, we will continue on the row operations. On the previous lecture that we did go through it previously, I will go through more exercises on the operation, and hopefully today we will be able to go to the inverse using the row operation, to get the inverse using row operations also. Remember, in the previous session, we spoke about Gauss-Jordan or the backward substitution method. I want to show you the differences between the echelon forms or the and the Gauss-Jordan or the backward substitution method. There is a slight difference between them. This is the updated method. This is the best of them, and I will tell you shortly about it. Of course, we have three main row operations. Row switching, which is develop an equivalent matrix, it will be the same almost. Row multiplication, if you multiply a complete row in a certain number, so the matrix values is going to be equivalent, or the row value will be equivalent. Multiplying any row by any scalar value and then adding the result on another row, it will be also the same. Remember the steps that we usually do. First of all, Osman, we will have a system of equations, which are the number of equations, the number of unknowns. The first step, we will try to arrange them, separate them into a coefficient matrix, as we will see in the coming slide, times the unknown matrix, which is going to be a column matrix, and is going to equal to another column matrix, which is the results of these equations. We can put them all together on the augmented matrix. It usually becomes like this. This is the coefficient matrix, and that's the result matrix. Using the row operations that we spoke about previously, if we succeeded in getting the equivalent form of the coefficient matrix to be changed to a unit matrix, then the solution set will be available for you, and you can find it for the solution of the system. We will go through one problem and we will see it. Of course, solving a system of equation will give you one option between three cases that you may encounter, which is to have a unique solution, or infinite number of solutions, or no solution. These are the three cases that we spoke about. Look, Osman, I know Rami, you know all about this, and Faris also. I want you to follow up with me. These are number of equations. As you see, every equation of those, it contains number of unknowns, which is from x1 up to xn. I usually have the same number of, add the same number of unknowns. I will have support same number of equations. That's for a balanced system of equations. And the results are b1, b2, bn. We already spoke about how to change a system to be the coefficient matrix times the unknown matrix, and which equal to the result matrix. And we can put it on the augmented form that I told you about. Okay, in a similar manner, this is exactly like the previous one, just showing that ax equal b, and this is for the coefficient and the unknown matrix. For the classification of systems, as we also talked in the previous lecture, you are in between three options. The first of them, Faris, if the system is consistent, and usually the consistent system will develop the same number of equations. For us, I'm sorry. صلحني علشان أنا مش داني غلط, okay? Okay, for us. يبقى إذن for a consistent system of equation, you should have the same number of equations equal to the same number of unknowns. But for a consistent system, you will have either one of these two cases. A unique solution case, when the number of equations equal exactly the number of unknowns and they are independent of each other, or infinite number of solutions, and this case will happen when the number of independent equations is less than the number of unknowns, or this case from the start, which is the case of inconsistent system of equations and it will have no solution. This will happen when you have one of your main equations depend on another one, and so it will, and there is difference in the results, and so it will develop unlogic solution for it. If we talk about ranks, I will talk about them shortly when we review the next example. But in general, we define the rank of a matrix as the number of pivot positions of any echelon form matrix row equivalent to n. Or in a more simpler manner, it is the number of the non-zero rows that exist in a matrix. Once you're trying to get the echelon, to get to the echelon form. So you count the number of rows, and this way you will get the number of, the number of rows, which is the rank of a matrix. What I want to show to you, if we are talking about a consistent system of equation which will develop either ways, there is a condition here, which is the rank of the matrix A should equal to the matrix to the rank of the augmented matrix. So let's say this is the first row in both matrices, this is the second in both matrices, the third in both matrices. So the R of A, which is the smaller matrix, equal exactly to the R of A star, which is the augmented matrix. This is the condition for you to have a solution for a system of equation. And if in the inconsistent system you will have these rows, this is the first, second, for example, this is the third row if we are talking about a 3 by 3 system, and you will find a number here. So if you try to find the ranks of the coefficient matrix, you will count these number of rows, so it's going to be Osman 2 of them. But if you go for the bigger matrix, it's going to be 3 of them non-zeros. So actually the R of A is not going to equal to the R of the augmented matrix, so the system from the start is inconsistent. Okay, if both of them equal to each other, when it's going to develop a unique solution, okay, it's going to be a unique solution if R of A equal R of the augmented matrix, and it's also equal to the number of the unknowns. Otherwise, you will have infinite number of solutions. Both three cases, I've solved with you 3 problems in the previous lecture on the unique solution, on the infinite number of solutions, and on the no solution case. Let's remember these steps, which is going to be easier for you to memorize it by another example. I believe this example I've left it for you in the previous session in order to solve it and try to train yourself on the various row operations that we may use. Okay. I want to solve this system of equation. Okay. The first step in order to solve such a system of equation is to first put it on matrix form, which is very, very simple. All you have to do, Osman, is to check something, that it is well arranged. So this is x1 above each through each other, x2 same way like, x3 same way, and that's for x4. The next step is trying to put them on a matrix form. Since I'm going to solve it by hand, I will put it directly on an augmented matrix. For us, how to put it on an augmented matrix? I will try to open matrix like this, and then I will have this line here, and I've told you about this line previously. It's like the one of the brackets and the x1, x2, x3, and the close of this matrix equal the other bracket, square bracket of the result matrix. This is what we denoted by this line. I will try to put the coefficients. Please try to put them arranged 1, 2, 3. Look for the signs. Be sure they are arranged. Then 1, 1, -1, +2. Then remark here there is no x3, so I will reserve its place by a 0. Then you will have -1, okay, -1. Then it is 3. You will have 3, 4 for the result, and for this one it's gonna be 1 and 1. For the last one it's gonna be 2 and -3. the last equation will be -1, then 4. Please check the numbers. Maybe I made a mistake or something. So it's 1, 1, 0, 3, 4, 2, 1, -1, 1. And I would recommend you to do this also once you are trying to solve any system like this. Okay?
What does the line mean again?
What?
The dotted line.
Well, just in a second. Okay. Boss, for us, mainly, this system of equation can be put in 3 matrices. The first of them is the coefficient matrix, which is 1, 2, 3, -1. The second column is going to be 1, 1, -1, and 2. The third one, there is no x3 here, so be careful about this. So it's 0, as I told you, -1, -1, and 3. This one is going to be 3, then 1, 2, -1. This is the coefficient matrix. This is what we call AS1. Then you will have the unknown matrix, which is x1, x2, x3, x4. This is the unknown matrix. And it's gonna equal to the results, which are 4 for the first equation, 1, -3, then 4 for the last one. The dotted line, it's like you canceled or you sum all this part. I will cancel it, and I will put instead of it this line. Okay. So actually, each row, it's exactly like an equation. The coefficients and the result. This is the augmented matrix. Okay? And this is why also we insisted on that you should check more than once the entries all together. معايا عبد الرحمن؟ عبد الرحمن؟ Okay. Next step. What are we going to do? Osman, we have 3 operations that we spoke about them in the previous lecture. What are the 3 operations? 3 row operation. The 3 row operations that you are allowed to use is you can move easily any one of these equations instead of the other one. So I can get the second equation, give it to you first, and get the first and put it in the second position. Is it going to make a difference with you? They will serve 4 equations, they are not depending on each other. The second thing, so switching rows, it's not going to affect, or it's equivalent, or row equivalent, to be by the exact meaning. If I want to multiply any of these equations in a constant number, in a scalar value, so it will stay balanced. This is why we are allowed to multiply in a row by a constant value, but you have to multiply all the entries from the start to the end. Also, I can take the second equation and add it to the third if I like. And also, I will still have a balanced equation, because you are taking a balanced equation, adding it on another one, so the result will be a balanced equation also. معايا فراس؟ Okay. يبقى ايه هم 3 properties or 3 operations that you can use? Switching rows, if you like, multiplying any row by a scalar value, multiplying any row by a scalar value in your head, then adding the result on another row. Okay? The plan is like this. I will try to be sure that the elements of the principal diagonal are positive 1. Then the rest of the values that exist in the matrix are equal to 0. How to do this step by step? I will start by the first element, which is 1, 1, and by chance also it's in here equal to 1. So I'm not going to exert any effort. Now I will start to open a new matrix. This is the new matrix that I will open. Look. It's going to be 1, 1, 0, 3, and 4. The first row, I'm not going to do anything on it. I will leave it as it is. Why for us? Because the value of the element 1, 1 is equal to positive 1.
Okay.
But I need to have the rest of the numbers in the first column equal to zeros. How to do this? By the row operations that we spoke about. Any ideas, Mr. Rami?
Okay. How do I make the second row first term?
Yes, the first term equal to 0. How to do it?
I'll multiply the first row by 2, then by -2, then add it to
More than perfect.
second.
If I want to get 0 Osman for us, I will multiply the pivot element, which is 1, by the number that I wanted to equal to 0, but with opposite sign, exactly like what Rami did. So I will get the first row, and I need 2 to change to be 0. I need to change 2 to equal to 0. So what I'm going to do, I will multiply all this row in the opposite number for this 2, which is -2.
So, yeah.
Okay, in my head, number by number. بص for us, Omar, Abdurrahman. Start multiplying. Okay, Rami, -2 plus 2 is going to equal to
0.
0. Repeat it, please, Osman. -2 plus 1, the result will be -2 times 0 plus -1, it's going to be -1. In a similar manner, -2 times 3 is going to be -6 plus 1, so it's going to come up to -5. -2 times 4, which is going to be -8. -8 plus 1, so the result will be -7. معايا for us?
Yeah, I got it, yeah.
Exactly the same. The next row, I want you to do it with me.
Okay.
So, for the next row, I should have here 0.
Yes, so.
But instead of 0, I have...
3, so we multiply by -3.
Okay, start multiplying.
So we're going to multiply.
-3 times 1
-3.
plus 3, so the result
0.
will be...
0. So we multiply
Repeat
by,
it.
by the first.
-3 plus -1, -4. -3 plus -1, -3 times 3, -9.
Yeah.
Plus +2, so then you will end up having -7. In a similar manner, -3 times 4, which is going to be -12. -12. -12 plus -3, so the result will be -15. أنا كده مظبوط رامي؟
We always multiply
Okay.
by the first row, yeah? Always.
Opposite sign.
Opposite sign, yeah.
Yes, but what goes for the first element, it goes for the whole row.
Yeah.
Okay, once more, Osman. I need this number to equal to 0. How to get this number equal to 0? We multiply 1
Times 3.
by the same number, but with opposite sign.
3.
No, positive 1.
الرو اللي تحتيه على أصلا.
Osman, شايف 3? Already changed it to be
0.
now. It is time on -1, and we need to change it to equal to 0. How to do it? I will stand by this +1, and then I will multiply it by this number, but with opposite sign. So -1, the opposite sign is going to be +1. Start multiplying the whole row, and the results, I will add them to the whole results of the 4th row. Okay? Huh? Cool?
-1 times 1 is
Okay. You said -1, yes? -1 plus -1, the result will be -2. It's not a 0. So I will have to multiply in +1. Start. +1 plus -1, the result will be. Repeat. +1 times 1
1.
plus 2, so it's gonna be. Once more, please. 1 times 0, it's gonna be.
0.
Plus 3, so it's gonna be. Once more. 1 times 3.
2.
1 times 3. 3.
3
Plus -1, so the result will be.
2.
Once more. 1 times 4 equal to 4. Plus 4, so the result will be 8. Okay? قول يا رامي.
Why don't I just add the rows? ما لو عملت 1 plus -1 هتديني 0.
Okay. which rows that you
The
need
first
to
and
add?
the last.
Okay, you can do that also. You can add the first row to the third row.
The row operation.
Okay, listen to me. For these row operations, you have multiple choice. It's numbers, so it's changing. So I can do like exactly what Rami said. I can simply add the first row to the last one, and this is the result. But I just want to train you on the simplest and the constant steps that you will use in most cases. You understand what I'm saying? If I want to get zeros, I will multiply the pivot, which is 1. In the same number, but with opposite sign. And then I will make the addition process. Okay? Once more. This is for the first column, it is correct. I need to go for the second column. نفس اللي انا عملته ده انا هريبيت التاني. Okay? Any ideas about the second column? I will start to open this matrix once more.
So we're gonna write the first row like the same as it is. 1, 1, 0, 3, 4.
No, but it will be 1, 0 above it, and all the rest of the results is gonna be. I'm seeking changing the principal diagonal. برضو كمان حاجة يا عثمان. This older matrix, don't you ever look at it again. Now I'm dealing with the last modified version. Okay? Okay. رامي أنا دلوقتي عايز أشتغل على second row. What to do يا عبد الرحمن؟ رأيك أعمل إيه؟ بص على second row. I need this number to be positive 1. But instead of positive 1, we have what to do? What do you suggest? ها؟ مين اللي بلس 2؟ انت ليه بتقول بلس 2 من تحت؟ ايه؟
مش احنا عايزين نكتب 1 بوزيتيف 1؟
نعمل ايه؟
بلس 2
مين اللي بلس 2؟
نكتب 1
I'm not allowed to add a number.
هنعمل الرو.
Okay. We have to do something for the whole row. We can't add a number. You are allowed to add a row, but not a number. But you can multiply by a number. صح؟ ها؟ قول لي كده. كويس؟ أنا ممكن أعمل كده، صح يا رامي؟ Multiply negative 1. So look to the second row, Osman. It's gonna be 0, then positive 1, then positive 1, then it's gonna be 5, and finally 7. Am I right? Okay, very good. I need the remaining elements in the second column to be all of them zeros. I will start with the one above. The one above it, which is, I need to multiply this row in a number. Once I add it on this one, the result will be 0. What to do? Which number? I need to multiply this one in certain number. Once I add it to 1, the result is going to be 0. What do you suggest? Negative 1. Okay? فاهم يا رامي ان انا ممكن اعمل حركه ثانيه بس مش عايز اعملها. عايز امشي على نفس الستبس دي، تمام؟
حضرتك عايز دايما تعمل مالتيبيكيشن باي سكيلر الاول بعديها ماشي.
عايز ادرب على ده لان ده اكتر حاجه الناس تستخدمها. اوكي مان، يلا عثمان اضرب. I will start multiplying by negative 1. Negative 1 times 0, 0. Plus 1, it's gonna be negative 1 plus 1, so the result will be negative 1 plus 0, so the result will be once more negative 5 plus 3, so the result will be another number, negative 7 plus 4, it's gonna be negative 3. I've adjusted the number above. For us, the number blue positive 1, which is
negative 4.
So I have to multiply this one by 4.
4, yeah.
By 4.
Yeah. And then
Positive, then I will add.
Yes. Okay.
So 4 times 0 equal to 0 plus 0.
0.
4 plus negative 4 is gonna be
0.
4 plus negative 1. You will end up having
3.
4 times 5 is gonna be 20.
20.
20 with negative 7 is gonna be 13.
Okay.
4 times 7 is gonna be 28.
Okay.
I believe 28 minus 15, so you will end up having 13. Okay?
Yeah.
عمور عمر
أنا
محمد انا اسف
ايوه
في عمر تاني وقع معانا راح فين؟ محول ولا عمل ايه؟ غايب النهارده برضه وغاب المره اللي فاتت. He was absent in the previous lecture. Yes. محمد قول لي النمبر اللي بعد كده ازاي اخليه بزيرو؟ ها؟
احنا دلوقتي وصلنا لزيرو، ممكن نعمل في السكند رو.
هو يعني عامل ايه يعني؟
ملتبلاي بنيجاتيف 3.
اوكي يبقى نيجاتيف 3 times 0 plus 0 the result will be negative 3 plus 3 it's gonna be the 0. Negative 3 plus 3 so it's gonna end up to 0. Negative 3 times 5 so it's gonna be negative 15 yes? Plus 2 so you will end up having negative 13. Then negative 3 times 7 which is gonna be negative 21. Negative 21 take 8 out of it so the result will be 13 I believe also. Yes? Negative 13 صح يا رامي؟ اوكي step اللي بعديه guys I need which number should equal to positive 1. I'm doing a 4x4 system.
The third row.
What's your what do you recommend? What's your recommendation?
We multiply by
Multiply the first row by multiply the first row by negative 3 and add it.
Okay. If I multiply the first row by 3,
elements.
this is gonna okay. You will lose the 0.
Can we multiply by?
And this is gonna be
3?
0, and they don't need it to be 0.
Can we multiply by 3?
But yes, 1 over 3. Actually, this is what I'm gonna do. I'm obliged to do this. So I'm gonna multiply by 1 over 3. So this row will change to be
0,
0,
0,
0, 1, 13 over 3, and yes?
Okay.
Similar manner. I need the numbers below the 1 to be zeros. We are lucky. It's already equal to 0. So all I have to do is write this thing exactly the same. 0, 0, 0, but it is the last row, yes? And we have negative 13. And for the coming steps, I will need to make it positive 1. So I will divide also on positive 1. I'm not obliged in this step, but why not to do it right now? I will do that, so it's going to be 1 and positive 1.
حضرتك عملتها divide by
Negative 13.
negative 15 divided by
Okay. It's exactly like multiplying the same row, all of it, times negative 1 over 13. معايا يا عثمان؟ Okay. Negative 1 over 13, negative 1. So we will end up like this. The next step is we need the number above 1 equal to 0, but it's actually equal to positive 1. ها؟ عبد الرحمن اعمل ايه؟ ازاي اخلي النمبر ده يبقى بزيرو وهو هنا بكام؟ يبقى ملتبلاي الرو ده كله في كام؟ نيجاتيف 1. نيجاتيف 1 times 0 plus 0 is going to equal to 0. Negative 1 times 0, 0 plus 1, 1. Negative 1 plus 1 is going to equal to 0. Negative 13 over 3 plus 15 over 3, you will end up having 2 over 3. Okay? تمام? Let's try it once more. I will multiply this row by negative 1 and I will add it on this value. So multiply negative 13 over 3. But this 21 over 3.
21 over 3.
So actually you have 21 over 3 and this one is negative 13 over 3. So it's really very simple. This is the 3, 21, take 13 out of it. So it's going to be negative 8. Am I right? Huh?
21, take 13 out of it, 8, which negative 8.
Okay, positive, yes, you are right. Okay. شباب متابعيني؟ Then we like أنا برضو عايز النمبر ده يبقى بكام؟
بزيرو.
But instead of 0 it has,
Like a one.
so I will add this row on the first row.
Okay.
Okay? Or multiply by positive 1 then add it. But it's similar to that. 0 plus 1 is going to equal to 1. يا عثمان انت متابعني 0 plus 0 is going to equal to 0. 1 positive or negative 1 is going to be 0 also. 13 over 3. The 13 over 3. And this is minus 6 over 3. Okay? So it's 13 over 3. I'm not seeing now negative 2. I can see it like negative 6 over 3, which is going to develop, take 6 out of this. So it's going to be 7 over. And in a similar manner, 13 over 3 and the negative 9 over 3, which is going to be 4 over 3. Okay?
The unique solution.
Yes? We are having one also. Okay. The last step. The last one. What's remaining to have? I need a unit matrix. So all the diagonal elements معايا small equal to positive 1. And the rest of the matrix will equal to, I am seeking to change them to be zeros. Okay? So the last step, I will open the last matrix. Here is the last matrix. Here we go. This is 1, 1, 0, 0, and 0. I will need the rest numbers here equal to zeros. This is what's called Gauss Jordan.
مش دي اللي reduced echelon form.
Before, this is the reduced echelon form.
لا
Just
لما
to get
خلص-
the numbers. بص في حاجة عايز أوضحها. بص يا رامي. The reduced echelon form is to have a lower and upper triangular matrix with the numbers that exist in above the diagonal, which is going to be positive 1. And then I will make a backward substitution. So I will start from the 1. The number here is going to be 1.
كله فوق يبقى zeros.
Yes, not the rest of them to equal to zeros. طيب خليني بس اخلص دي. I will complete this one and I will tell you the difference between Gauss-Jordan elimination and the echelon, the exact echelon form. Okay? Once more, we reached 1 and the others equal to 0. Okay, عثمان ايه الرقم اللي بعديه اللي المفروض تبقى 0؟ لا، ال1 ده مش هقدر اعمله، ده principal there. What I need to equal to 0, which is 13 over 3. How to do it once more? I will multiply this one and the same number, but with opposite sign. So I will take the last row and I will multiply it by negative 13 over 3. Start multiplying. Negative 13 over 3 times 0 equal to 0 and 0. So it's gonna be 0. Somewhere like for all of these zeros, it will keep the other row or the row above in a similar manner, except for this number, negative 13 over 3 plus 13 over 3 will develop 0. And I'm really looking for that. Negative 13 over 3 times 1, negative 13 over 15. Plus 13 over 13 also equal to 0. Similar manner. I need this number to be here equal to 0. So I will multiply the positive 1 and negative 2 over 3. Negative 2/3 plus 2 over 3, the result is going to be 0. Remark, all these numbers are not going to change because this part of this row, the last row, are all zeros. Okay, Shabbat? Then negative 2 over 3 plus 8 over 3, you will end up having 6 over 3, which is simply 2. معايا؟ عبد الرحمن معايا؟ تقدر تقول لي آخر واحد أعمل إيه؟ آخر حركة؟ فاضل الفيرست رو بس. ها الفيرست رو موجود فيه مين؟ وانت عايزها تبقى بكام؟ 0. So البوزيتيف 1 هيبقى multiplied بنفس الفاليو بس with negative sign. يبقى negative 7 over 3 plus 7 over 3 is going to equal to 0. Negative 7 over 3 plus 4 over 3 is going to be negative 3 over 3, which is negative 1. The rest of the matrix is exactly the same. Now we succeeded in getting a unit matrix of this dimension, which is 4 by 4. Okay? If I tried to expand it once more to the original form of these equations, we all of us know that this is the column of x1, this is the column of x2, and that's x3, and the last one is for x4. So simply 1 times x1, it's going to be x1, which equal to -1. And the 0 times x1, 1 times x2, so it's going to be x2, which corresponds to 2. x3, in a similar manner, 1 times x3 is going to equal to 0. And the last one, x4, equal to +1. These are the results, the solution set for this system of equation.
Okay, it's consistent.
Okay.
Independent.
Of course it's consistent.
Consistent, independent.
Consistent and independent system. Consistent, it means your system is very strong. All the equations are independent. That's will develop a unique solution. يعني ايه unique solution يا عثمان? Just only the set of numbers -1, 2, 0, and 1. It will make these 4 equations all correct. If you change anything, you will never get all of them correct. So, if I want to try the first one, just replace x1 by -1, x2 by 2, so the result is going to be +1, x4 replace it by 1, 1 plus 3 equal 4, left equal to right, and so on for all of them. Let's talk ranks. Let's talk about ranks. Once I reach this step, running, how many non-zero rows in the smaller matrix, in this matrix?
4.
This matrix only. This is the 1, 2, 3, and 4. So the rank of the coefficient matrix equal to 4. What is the rank of the whole system? خلي بالك يا عبد الرحمن. The whole system يعني معناها starting from this bracket to the first bracket. So you're actually talking also about this column. معايا يا عبد الرحمن? This is a non-zero row, this is non-zero row, this is non-zero row. Same way like, so it's equal to R is